carbonyl group. If the H is attached, then it will become the aldehyde. Secondary alcohol with this KMNO4 ಮತ್ತೆ potassium dichromate ಈ ಎರಡು ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ it will give the ketone only, but primary alcohol it will give the carboxylic acid. Most of the chiral carbons are optically active, not all the chiral carbons, most of the chiral carbons. Electrophilic substitution reaction. Now electrophilic substitution reactions are very very important. Now ಯಾಕಂದ್ರೆ hello my dear friends, ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. myself ಕೋಡ ನವೀನ್ ಕುಮಾರ್, ನಿಮ್ಮ ಕೆಮಿಸ್ಟ್ರಿ ಫ್ಯಾಕಲ್ಟಿ. I welcome back you all to this incredible platform physics wala. ನಾನು ಇವತ್ತು ನಿಮ್ಮ ಮುಂದೆ ಬಂದಿದ್ದೀನಿ with the summary lecture. ಈ summary lecture ಅಲ್ಲಿ ಏನಂದ್ರೆ this is very very important for your JEE mains, NEET as well as the KCET. ಈಗ ನೀವು detailed lecture of the aldehydes ketone carboxylic acid detailed lecture ನೋಡಿಲ್ಲ ಅಂದ್ರೆ this will not be useful for you. ಓಕೆ, ಮೊದಲು ನೀವು ಏನ್ ಮಾಡಂದ್ರೆ ಹೋಗಿ ಆ ಡೀಟೇಲ್ ಲೆಕ್ಚರ್ ನೋಡಿ, ಆಮೇಲೆ ನೀವು ಕಮ್ ಅಂಡ್ ಸಿ ದಿಸ್ ಲೆಕ್ಚರ್. ಯಾಕಂದ್ರೆ ದಿಸ್ ವಿಲ್ ಬಿ ಹೆಲ್ಪ್ಫುಲ್ ಫಾರ್ ಯು ಯುವರ್ ಫಾಸ್ಟ್ ಪ್ರಿಪರೇಷನ್. ದಿಸ್ ಇಸ್ ಅ ಸಮ್ಮರಿ. ಡೀಟೇಲ್ಡ್ ಏನಿರಲ್ಲ ಇಲ್ಲಿ, ಜಸ್ಟ್ ಸಮ್ಮರಿ. ಸಿನಾಪ್ಸ್ ಇರುತ್ತಲ್ಲ ಸೇಮ್, ಬಟ್ ಇಟ್ ಈಸ್ ಯೂಸ್ಫುಲ್ ಫಾರ್ ಯು ವೆನ್ ಯು ಹ್ಯಾವ್ ಪ್ರಿಪೇರ್ಡ್ ವೆಲ್ ಅಂಡ್ ವೆನ್ ಯು ಹ್ಯಾವ್ ಸೀನ್ ಯುವರ್ ಡೀಟೇಲ್ಡ್ lecture, then this video and this lecture will be useful for you. Okay, now let's start our summary lectures of the aldehydes, ketones and the carboxylic acid. Now first introductions of the aldehydes, ketones and the carboxylic acid. Now for all the common it will be carbonyl group. For all it will having the carbonyl group is a common. ಈಗ ಈ carbonyl group ಗೆ if the H is attached, then it will become the aldehyde. Now if CH3 is attached, let us assume this is CH3. Now if the CH3 is attached both sides, now then it will become the ketone. Iga if OH is attached, then it will become the carboxylic acid. Now carbonyl group hybridization ಏನಂದ್ರೆ hybridization ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡಬಹುದು? Hybridization is equal to number of sigma plus number of lone pairs ಅಲ್ಲ, number of sigma plus number of lone pairs. ಇಲ್ಲಿ ನೋಡಿ number of sigma bonds ಎಷ್ಟು? 1 2 3. ಈಗ number of sigma bonds 3 ಅಂದ್ರೆ hybridization is sp2. now this carbonyl group carbon hybridization is sp2. ಈಗ carbonyl group ಗೆ H ಇದೆ ಅಂದ್ರೆ that is aldehyde. ಈಗ CH3 ಇದೆ ಅಂದ್ರೆ ketone. ಈಗ OH ಇದೆ ಅಂದ್ರೆ that is carboxylic acid. Next we'll see the some nomenclatures of the carbonyl groups. ಈಗ carbonyl group ಗೆ some nomenclatures of the compound ನೋಡೋಣ. now first this is a acetaldehyde. CH3 C double bond OH ಇದೆ ಅಂದ್ರೆ this is acetaldehyde. now ಇದು if this compound if you seen that is a benzaldehyde. now ಇದು if you have seen this one salicylaldehyde, this is salicylaldehyde. now or 2-hydroxy benzaldehyde. ಇದು ಕಾಮನ್ ನೇಮ್. this is IUPAC name. next ಈಗ we have seen with this benzene, we have seen with the aromatic ring or benzene ring ಅಲ್ಲ. now if cyclic group is attached, ಈಗ cyclic group is attached ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ aldehyde group is attached on a cyclic compound, a suffix carbaldehyde. suffix we have to use the carbaldehyde when the aldehyde group is attached to the cyclic compound, when it is attached to the cyclic ring, now then it will become a cyclohexane carbaldehyde. ಇಲ್ಲಿ ನೋಡಿ cyclobutane carbaldehyde. okay, next for the ketones. ಈಗ ketones ನೋಡೋಣ. now this middle it is the carbonyl group with the middle it is having the ketone group ಅಲ್ಲ, ಇದು ketone group CH3 3H3. now common name ಏನು for this one? this is a acetone. common name is the acetone. IUPAC name ಏನು? propanone. one is a this is the functional group. For the suffix we have to use. Now next, this is the acetophenone. ಈಗ ಈ ಕಾಂಪೌಂಡ್ ನೋಡಿದ್ರೆ ಅಂದ್ರೆ now this is a acetophenone. This is benzophenone. This is a benzophenone. Clear? Next, ಈಗ some compounds common names ಮತ್ತೆ IUPAC names ನೋಡೋಣ. ಇಲ್ಲಿ ನೋಡಿ ಫಸ್ಟ್, ಈಗ if HC double bond H, ಈಗ ನೋಡಿದ್ರೆ this is formaldehyde. IUPAC name is a methanol. Formaldehyde in the methanol. ಈಗ organic chemistry ಅಲ್ಲಿ most of the times ನಿಮಗೆ ಅದು ರಿಯಾಕ್ಷನ್ ಗೊತ್ತಾಗುತ್ತೆ, ಬಟ್ ಪ್ರಾಡಕ್ಟ್ IUPAC ನೇಮ್ ಕೇಳುತ್ತೆ. They will ask product IUPAC name. That's the reason now remembering of the common names and the IUPAC names of the any compounds, it is very very important. If you want to study, if you want to score more marks in your organic chemistry, first what you have to be perfect in the IUPAC. First you have to be perfect in the IUPAC. Okay, now iga this is formaldehyde or methanol. Now this is acrolein prop-2-enol. Next, this is phthalate or benzene 1,2 dicarbaldehyde. Now this is diethyl ketone. This is ethyl and this is the ketone ala pent 3-one. Now this is a cinnamaldehyde. These are the common names, are very very important. These compounds are very very important. Yakandre products alli common name or else IUPAC name they are asking. Okay, next, ಈಗ preparations of the aldehydes and the ketones. Preparations of the aldehydes and the ketones ಹೆಂಗ್ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು ಅಂದ್ರೆ, ಫಸ್ಟ್ ಏನ್ ನೋಡ್ಬೇಕಂದ್ರೆ, ಫಸ್ಟ್ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ಅಂದ್ರೆ, ಫಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ಪ್ರಿಪರೇಷನ್ ಆಫ್ ದ aldehydes and ketones, ಆಮೇಲೆ ಇಟ್ಸ್ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ, ಆಮೇಲೆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್. ಫಸ್ಟ್ ಹೌ ವಿ ಪ್ರಿಪೇರ್ ದ aldehydes and the ketones ಅಂತ ಒಂದ್ಸರಿ ರೀಕ್ಯಾಪ್ ಮಾಡೋಣ. Now let's see. First, aldehydes and ketones can be prepared from the by oxidation. This is by oxidation. By oxidation of alcohols. One thing, ಈಗ ಇವು this chart ಈಗ ನೀವು ನೆನಪಿಟ್ಕೊಂಡ್ರೆ you can attempt the answer very fastly. ಇಲ್ಲಿ ನೋಡಿ, if the primary alcohol ಕೊಟ್ಟಿದ್ರಂದ್ರೆ, ಈಗ primary alcohol ಕೊಟ್ಟಿದ್ರಂದ್ರೆ, here if they have given a Collins reagent and a pyridine in the presence of CrO3 in the presence of CH2Cl2, ಈಗ this reagent ಈಗ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ, and if it is a primary alcohol, reactant is a primary alcohol and the reagent is a Collins reagent, that directly it will be converted into aldehyde. Now secondary alcohol will be converted into ketone. Okay, now tertiary alcohol will not be converted. Yakandre here there is no acidic hydrogen, or alpha hydrogen. Now next, PCC ಮತ್ತೆ Collins reagent ಏನ್ ಮಾಡುತ್ತೆ, first primary alcohol it will be converted into aldehyde and the secondary alcohol it will be converted into ketone. Okay, ಈಗ ನೀವು ಸ್ಟ್ರಾಂಗ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ತಗೊಂಡಿದ್ವಿ ಅಂದ್ರೆ, ಸ್ಟ್ರಾಂಗ್ ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಯಾವ್ದಂದ್ರೆ ಪೊಟ್ಯಾಷಿಯಂ ಪರ್ಮ್ಯಾಂಗನೇಟ್ ಮತ್ತೆ ಪೊಟ್ಯಾಷಿಯಂ ಡೈಕ್ರೋಮೇಟ್. ಈಗ ಎರಡು ನೀವು ತಗೊಂಡಿದ್ವಿ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, primary alcohol will be converted into carboxylic acid. But ಈಗ ನೀವು ಸ್ಟ್ರಾಂಗ್ what if you taken the KMnO4, if you take the KMnO4 or K2Cr2O7, now these are the strong oxidizing agents. These strong oxidizing agent primary alcohol ni ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ, it will convert into carboxylic acid. But we are going to see only the aldehydes ಮತ್ತೆ ketones ಅಲ್ಲ, ಅದಕ್ಕೆ ನಾನು I was not said this one. But ಈಗ ಇದು secondary alcohol ಕೊಟ್ಟಿದ್ರ ಅಂದ್ರೆ, secondary alcohol with this KMnO4 ಮತ್ತೆ potassium dichromate, ಈ ಎರಡು ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ, it will give the ketone only. But primary alcohol it will give the carboxylic acid. 1 degree alcohol. 1 degree alcohol will give the carboxylic acid, secondary alcohol will give the ketone. Okay, now tertiary alcohols will not react with this reagent. Next preparation of aldehydes and ketones with the metal Cu or Ag in the presence of 300 degree high temperature. Primary alcohol will convert into aldehyde. Now secondary alcohol will be converted into ketone. Now tertiary alcohol with this metal at the high temperature ಏನಾಗುತ್ತಂದ್ರೆ it will not give aldehydes and ketone, but it will give the alkene. Okay, it will give the alkene. You have to be very careful. ಮತ್ತೆ KMnO4, K2, Cr2O7 Collins reagent PCC with the 3 degree alcohol, it will not react. Only it will react with the metal at high temperature. ಏನಾಗುತ್ತೆ that also it will convert into alkene. Okay, next another method of the preparations of the aldehydes and the ketones by the hydrocarbons ಇಂದನು we can prepare the aldehydes ಮತ್ತೆ ketones. ನಾವು ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, this is alkene in the presence of ozone, it will give the what is this? If here this is carbonyl, 2 moles of carbonyl. Here if I take CH3, now ಇದರಲ್ಲಿ ಒಂದು H, ಇದರಲ್ಲಿ ಒಂದು H. If I take what is this? Butene, 1 2 3 4 ಅಲ್ಲ, butene. ಈಗ ನಾನು butene ತಗೊಂಡಿದ್ದೀನಿ ಅಂದ್ರೆ now what it will give? 2 moles of formaldehyde. 2 moles of what it will give? 2 moles of acetaldehyde it will give ಅಲ್ಲ. Now 2 moles of CH3 C double bond 2, right? Now ಈಗ ozonolysis of alkene ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ನೀವು ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. what you have to do means break the double bond, put one oxygen here and put one oxygen here. By this we can prepare the acetaldehyde, we can prepare the aldehyde. Okay, now in the place of this one ಮತ್ತೆ in the place of this one ಈಗ H ಈಗ if this they have given, what is this? This is ethene. ಈಗ ethene ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now what it will become? Put the one oxygen here, put the one oxygen here. No, here one nitrogen, here one nitrogen, here one nitrogen. ಏನಾಗುತ್ತೆ? This will become the 2 moles of formaldehyde. ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. ಫಸ್ಟ್ ಆಕ್ಚುಲಿ ಇಂಟರ್ಮೀಡಿಯೇಟ್ it will form the ozonide to give the product, but ಈಗ ozonolysis, ozone in the presence of CCl4. ಈಗ ಈ reagent ಈಗ ನೋಡಿದೀವಿ ಅಂದ್ರೆ ozonolysis ಅಂತ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ what you have to do? Break the double bond, put one oxygen here, put one oxygen here, ನಿಮಗೆ that product ಬರುತ್ತೆ. Clear? Next now ಈಗ just now we have seen the aldehyde ಅಲ್ಲ. now ಈಗ this reagent ಈಗ sorry ಈ reactant ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ now the reagent, this is ozone, O3. now in the presence of CCl4 now gives acetaldehyde as well as the ketone. ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, break the double bond, put the one oxygen here, put the one oxygen here, then it will become CH3 C double bond O H. ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ double bond, now C CH3 CH3. now this is acetaldehyde, this is a acetone ಅಲ್ಲ. now from the ozonolysis ಇಂದನು we can prepare the aldehydes ಮತ್ತೆ ketones. next now by the hydration of the alkanes ಇಂದನು we can prepare the aldehydes ಮತ್ತೆ ketones. ಇಲ್ಲಿ ನೋಡಿ, here this is ethine ಅಲ್ಲ, ethine triple bond ಅಂದ್ರೆ ಐನ್ ಅಲ್ಲ. now if I shift this bond to this carbon ಏನಾಗುತ್ತೆ? CH double bond, CH negative ಅಲ್ಲ. now here H2O, now H2O, now what it will do? one H plus it will be attacked here. now ಇದರಲ್ಲಿ ಪ್ಲಸ್ ಆಗುತ್ತಲ್ಲ, now OH minus it will be attacked. now attacked to give ಏನಾಗುತ್ತೆ? this is double bond, now OH, now this is CH2. Now this is the enol. Enol is the unstable. Enol is the unstable. ಏನಾಗುತ್ತೆ ಅಂತ 1,3 proton transfer. 1,3 proton transfer. ಅಂದ್ರೆ 1,3 proton transfer ಅಂದ್ರೆ tautomerization will be takes place. Tautomerization will be takes place. Now this proton will go and attack here and will get the aldehyde. CH2 and it will give the enol alla. Okay. Next. From the acid chlorides. From the acid chlorides indano we can prepare the aldehydes ಮತ್ತೆ ketones. Aldehydes in the acid chlorides. Now this is the acid chlorides. Acid chlorides by the Lindlar's catalyst. Lindlar's catalyst ಏನಂದ್ರೆ palladium barium sulfate poisoned by the trace sulfur or quinoline. Trace sulfur or quinoline. ಇದು if it is attacking to the triple bond, Lindlar's catalyst in the presence of ethane or any triple bond, it will stop the reaction at the alkene stage. It will stop the reaction at the alkene stage if it is reacting with the alkene. If it is reacting with the alkyne, sorry, if it is reacting with the triple bond. Here triple bond, if this Lindlar's catalyst reacting with the triple bond, it will stop the reaction at the double bond. If it is reacting with the acid chloride, now what it will do? Now ಏನು ಮಾಡುತ್ತೆ? It will give the aldehydes. Now this reaction we call it as a Rosenman reaction. Now Lindlar's catalyst in the presence of trace poisoned sulfur and the quinoline. If it is reacting with the triple bond, it will stop the reaction at the alkene stage. If it is reacting with the acid chlorides, now these are the acid chlorides. If it is reacting with the acid chlorides, what it will give? It will give the aldehydes. Next. Aromatic ketones can also be prepared from the acid chlorides. Now this is acid chloride alla. Now this is anhydrous AlCl3. Anhydrous AlCl3 is a Lewis acid. Lewis acid will accept the electron due to the presence of vacant orbital. Now this will accept the chlorine. And the chlorine will get the positive charge. Here this electrons chlorine mele lone pair idiyalla, this lone pairs will be accepted by this Lewis acid. ಈಗ lone pair has been given to the Lewis acid alla. Now ಏನಾಗುತ್ತೆ? This will become double bond and it will become positive charge alla. Now this chlorine more electronegative group bearing the positive charge. Is unstable. ಏನಾಗುತ್ತೆ? To make the stable, this sigma bond will be given to this chlorine and the electrophile will be generated. Now this electrophile will go and attack to the benzene ring and it will give the acetophenone. Now by acid chlorides indanu we can prepare the ketones. Now acid chloride with the Lindlar's catalyst or Rosenman reduction indanu we can prepare the aldehydes. By this we can prepare the ketones. Now idರಲ್ಲಿ ನೋಡಿ. Now this is the phenyl alla. Now by this we can prepare the diphenyl ketone. We can prepare the acetone. Next. From the reduction of alkali, cyanide and nitriles and the ethers. Now by this also, by alkali cyanides, by cyanides indanu we can prepare the aldehydes. ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, this is stannous chloride, this is SnCl2. Stannous chloride in the presence of HCl. Now what it will happen? Stannous chloride in the presence of HCl, it will react to give the SnCl4 plus H2. SnCl4 plus H2. Now you'll notice this has been oxidized alla from the tin +2 oxidation in the +4 ಹೋಗಿದಲ್ಲ by loss of 2 electrons. ಇಲ್ಲಿ ನೋಡಿ ಕಾರ್ಬನ್ ಮತ್ತೆ ನೈಟ್ರೋಜನ್ ಅಲ್ಲಿ which is a more electronegative? Nitrogen is more electronegative alla. Now this bond will be shifted toward the nitrogen. Now ಏನಾಗುತ್ತೆ? This will get the negative charge and this will get the positive charge alla. Now positive charge ಇದರಲ್ಲಿ 2 electrons ಇದೆಯಲ್ಲ, by tin has lost the 2 electrons alla. Now by taking these 2 electrons, now carbon ಮೇಲೆ ಏನಾಗುತ್ತೆ? Carbon ಮೇಲೇನು negative charge ಆಗುತ್ತೆ. Carbon ಮೇಲೆ negative charge ಆಗುತ್ತಲ್ಲ. Now here we are having H and the H. Now this H will go and attack here and this H will go and attack here, and by this we will get this product. By this we will get this intermediate. Now by that imine by hydrolysis we are getting the, by that hydrolysis we are getting the aldehyde. By that hydrolysis we are getting the aldehyde. Okay. Next. Next, dibol H. ಈಗ ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. in the question if they ask dibol H, ಈಗ in this question if they ask dibol H ಅಂತ ಕೇಳಿದ್ರಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, see, the first it will be reduced to the imines, which on subsequent hydrolysis form the aldehydes, only it will reduce the this nitrile group. Okay, first it will reduce the nitrile group to the aldehyde. Dibol H, ಈಗ dibol H upon hydrolysis what it will give, it will give the aldehyde. Which one it will be reduced? It will reduce the only the nitrile group or cyanide group. This cyanide group will be converted into aldehyde in the presence of dibol H. Okay, next. Next, see, benzaldehyde from the hydrocarbon. ಈಗ aldehydes we can prepare from the hydrocarbons indanu by the oxidation of methyl benzene. Oxidation of methyl benzene, first that we call it as a Itard reaction. ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು what this means. Here this reagent chromyl chloride in the presence of CS2, chromyl chloride in the presence of CS2 in the presence of toluene in the presence of chromyl chloride, what it will be converted? It will be give the benzaldehyde. Now this will give the chromyl complex. First this will give the chromyl complex, then this complex upon hydrolysis it will give the aldehyde. Which aldehyde? Benzaldehyde. Toluene will be in the presence of Itard reaction reagent ಯಾವುದು? CrO2 Cl2. This is chromyl chloride. First it will give the complex, this complex upon hydrolysis it will get the benzaldehyde. Okay, next, uses of chromic oxide indanu we can prepare the aldehyde. Now chromic oxide andre enu? This is CrO3 plus CH3 CO2O. This is acetic anhydride. Idu acetic anhydride in the presence of 0 to 10 degree. First it will give the benzylidene diacetate. This will give this intermediate, and this intermediate upon hydrolysis again will get the benzaldehyde. Now here in the math the following, sometimes iga JEE mains allo ಮತ್ತೆ NEET allo ಮತ್ತೆ KCET allo now ಏನು ಕೇಳುತ್ತೆ ಅಂದ್ರೆ, now benzaldehyde can be prepared from match the following. In the match the following they may ask, we are having the chance, match the following: toluenes upon Itard reaction, toluene upon chromic oxide. Now what the product it will give? It will give benzaldehyde. And it will give the, what is this? 2 moles of acetic acid. Next, by this also we can prepare the benzaldehyde. Next, by the chlorination of the side chain followed by hydrolysis. Now by this method also we can prepare the aldehyde. Engandre illi nodi, first this is chlorination. This is following the free radical mechanism. Now here chlorination alli now ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ chlorine will be attacked at the side chain carbon. Now ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ this is here benzene ಅಲ್ಲಿ here the double bond, here the double bond, here the double bond ಇರುತ್ತಲ್ಲ, here the double bond ಇರುತ್ತಲ್ಲ. Now functional group adjacent carbon, that is allyl carbon ಅಲ್ಲಿ free radicals are more stable. ಯಾಕಂದ್ರೆ it is stabilizing by the delocalization. ಅದಕ್ಕೋಸ್ಕರನೇ CL2 will be this, CL2 will be attacked at the side chain carbon. ಅಲ್ಲಿ ಇದರಲ್ಲಿ free radicals are stabilizing by the delocalization of this pi electron. ಅದಕ್ಕೋಸ್ಕರನೇ it will attack at the side chain. Alkyl, and it will eliminate as a -2 HCl. It will be eliminated and it will give the benzyl chloride. Benzyl chloride upon hydrolysis will give here the again as the HCl, 2 moles of HCl it will be eliminated. 2 moles of HCl, ಇದರಲ್ಲಿ 2 moles of HCl it will be eliminated. ಇದರಲ್ಲಿ 2 moles of HCl it will be eliminated, and it will 2 hydroxy groups will be attacked. 2 hydroxy groups will be attacked. Now ಈಗ ಒಂದು ಕಾರ್ಬನ್ ಮೇಲೆ 2 hydroxy groups ಇದೆ ಅಂದ್ರೆ that carbon is unstable. ಇಲ್ಲಿ ನೋಡಿ ಒಂದೇ ಕಾರ್ಬನ್ ಮೇಲೆ 2 hydroxy groups ಇದೆಯಲ್ಲ, ನಾವು then that carbon is unstable. To make it stable ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ elimination of water molecule will be happened. Elimination of water molecule ಹೆಂಗಂದ್ರೆ now this sigma bond will be shifted here. Now this oxygen, it will take the bond pair of electron. This oxygen will take the bond pair of electron towards itself. When it is taking the bond pair of electron towards itself, now it will get the negative charge alla. Now here the hydrogen, it is having the positive charge. Now this 2 will attack and the elimination of H2O. Now ಒಂದು ಕಾರ್ಬನ್ ಮೇಲೆ 2 ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್ಸ್ ಅಟ್ಯಾಚ್ಡ್ ಇದೆ ಅಂದ್ರೆ ಆ ಕಾರ್ಬನ್ ಇಟ್ ಈಸ್ ಅನ್ಸ್ಟೇಬಲ್. ಟು ಮೇಕ್ ದಟ್ ಕಾರ್ಬನ್ ಸ್ಟೇಬಲ್ ಏನ್ ಮಾಡಬೇಕು, ಎಲಿಮಿನೇಷನ್ ಆಫ್ ದ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಈಗ ಎಲಿಮಿನೇಷನ್ ಆಫ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್, ಆಮೇಲೆ ಏನಾಗುತ್ತೆ, ನಾವು ವಿಲ್ ಗೆಟ್ ದ product. ಅದು ಯಾವ್ದು ಪ್ರಾಡಕ್ಟ್, benzaldehyde. Benzaldehyde is a product. Now by this also we can prepare the aldehydes. By this also we can prepare the aldehydes. Next by nitriles indano we can prepare the aldehydes. By the nitriles indano we can prepare the aldehydes. ಇಲ್ಲಿ ನೋಡಿ, now this is a Grignard reagent. Grignard reagent ಅಲ್ಲಿ most of the times ಕಾರ್ಬನ್ ಎಲೆಕ್ಟ್ರೋಪಾಸಿಟಿವ್ ಸ್ಟೇಟ್ ಅಲ್ಲೇ ಇರುತ್ತೆ. But when it is attacked to the metal, metal ಇದು Mg is metal ಅಲ್ಲ, metal, this is group 2 metal. Group 1 and the group 2 and the group 2 metals are electropositive in nature. ಯಾಕಂದ್ರೆ if the group 1 metal, if they last one electron, it will reach to the noble gas electronic configuration. Now group 2 metals, if they last the 2 electrons, it will reach to the noble gas electronic configuration ಅಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರನೇ metals always exist in the which state? It will exist in the electropositive state only. ಅದಕ್ಕೋಸ್ಕರನೇ this metal will get the positive charge and this carbon or alkali will get the negative charge. ಇಲ್ಲಿ ನೋಡಿ, now this carbon ಮತ್ತೆ nitrogen is a more electronegative group ಅಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರನೇ this pi bond will be shifted toward this nitrogen. ಕಾರ್ಬನ್ ಮೇಲೆ ಯಾವ ಚಾರ್ಜ್ ಬರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ಲ. now here this group, it will go and attack here and it will give this intermediate. now upon hydrolysis what we are getting the 2-butanone and the ammonia and the magnesium hydroxybromide. By this nitriles also we can prepare the ketone or ketones and the aldehydes. Next physical properties of the aldehydes and the ketones. ಈಗ physical properties of the aldehydes and the ketones ಅಂತ ಏನಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, solubility first. aldehydes ಮತ್ತೆ ketones, due to the hydrogen bonding, solubility of these compounds decreases rapidly. ಇಲ್ಲಿ ನೋಡಿ, if I take CH3, C double bond O H, now next ಇನ್ನೊಂದು ಕಾಂಪೌಂಡ್ if I take, now ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ this is ಇದರಲ್ಲಿ if I take CH3, C double bond O, now ಇದರಲ್ಲಿ H, now intramolecular hydrogen bonding. Due to this intramolecular hydrogen bonding ಏನಾಗುತ್ತೆ, chain length will be increased. See, rapidly on increasing the length of alkali group. Now chain length will be increased. ಈಗ chain length increase ಆಗಿದೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ, solubility decrease ಆಗುತ್ತಲ್ಲ. ಯಾಕಂದ್ರೆ due to the intermolecular hydrogen bonding, not I am saying intramolecular ಅಂದ್ರೆ within the molecule, intermolecular ಅಂದ್ರೆ between the two molecules. Okay, now due to this solubility decrease ಆಗುತ್ತೆ. next boiling point. now boiling point ಅಲ್ಲಿ ಇಲ್ಲಿ ನೋಡಿ, n-butane ಮತ್ತೆ methoxyethane, n-butane ಮತ್ತೆ n-butane ಅಲ್ಲಿ there is no hydrogen bonding. now due to the absence of hydrogen bonding, now n-butane boiling point is less. even though ಇಲ್ಲಿ ನೋಡಿ propanol ಅಲ್ಲಿ ಮತ್ತೆ n-butane ಎರಡು it is having the same molecular mass. then propanol should also have same boiling point ಅಲ್ಲ, but propanol ಗೆ ಜಾಸ್ತಿ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಯಾಕಂದ್ರೆ it is having hydrogen bonding. ಇದು propanol. No. Here due to the presence of hydrogen bonding, now this acetone ಮತ್ತೆ propanol ಎಲ್ಲಾನು ಡ್ಯೂ ಟು ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. ಈಗ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ ಅಂದ್ರೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ನು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್. ಈಗ ಪ್ರಿಪರೇಷನ್ಸ್ ಆಫ್ ದ ಆಲ್ಡಿಹೈಡ್ಸ್ ಕೀಟೋನ್ಸ್ ನೋಡಿದೀವಲ್ಲ. ನಾವು ಆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಮತ್ತೆ ಕೀಟೋನ್ಸ್ ಹೆಂಗ್ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ, ಹೌ ದೇ ವಿಲ್ ರಿಯಾಕ್ಟ್ ಅಂತ ನೋಡೋಣ. ಫಸ್ಟ್ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್. ಆಲ್ಡಿಹೈಡ್ಸ್ ಮತ್ತೆ ಕೀಟೋನ್ಸ್ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಇಟ್ ವಿಲ್ ಶೋ ದ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್. ಇಲ್ಲಿ ನೋಡಿ, ಕಾರ್ಬೊನೈಲ್ ಕಾಂಪೌಂಡ್ ಅಂಡರ್ಗೋಸ್ ದ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್. ಈಗ ಕಾರ್ಬೊನೈಲ್ ಗ್ರೂಪ್, ಇದು ಕಾರ್ಬೊನೈಲ್ ಗ್ರೂಪ್ ಅಲ್ಲ, ಕಾರ್ಬೊನೈಲ್ ಗ್ರೂಪ್ when the weak nucleophile is given. ಈಗ weak nucleophile is given, ನಾವು ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ this carbonyl group ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಲೋನ್ ಪೇರ್ ಇರುತ್ತಲ್ಲ, it will take the here weak nucleophile. ಈಗ weak nucleophile ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ನಾವು ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಫಸ್ಟ್ it will take the hydrogen. ನಾವು ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಬರುತ್ತಲ್ಲ, to stabilize this oxygen now pi bond will be shifted. now then the carbon ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ, then the nucleophile will be attacked. If they have given the weak nucleophile, carbonyl group nucleophilic addition reaction, they will take in this manner. The process they will take in this manner. But ಈಗ strong nucleophile if they have given or weak nucleophile if they have given, the product will be same. But ಇದರಲ್ಲಿ ಸ್ಲೋ ಸ್ಟೆಪ್ ಅಂಡ್ ಫಾಸ್ಟ್ ಸ್ಟೆಪ್ ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. ಇಲ್ಲಿ ನೋಡಿ, ನೆಕ್ಸ್ಟ್ if they have given strong nucleophile ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಫಸ್ಟ್ attack of the nucleophile will be takes place. Then the attack of the H plus will be takes place. Attack of the H plus is fast step. This is fast step. Now attack of the nucleophile is slow step. Okay, in the presence of strong nucleophile, but the product is same. Only the slow ಮತ್ತೆ fast attack of the. ಈಗ strong nucleophile ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಫಸ್ಟ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಈಗ ವೀಕ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಲಾಸ್ಟ್ the nucleophile will be attacked. Now this is the addition reaction. Now reactivity order, this is very important. Now carbonyl groups will show the nucleophilic addition reaction ಅಲ್ಲ. nucleophile charge ಏನು, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಲ್ಲ. nucleophile charge is the negative charge. This is nucleophile is the negative charge. Now ಈಗ ಈ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಕಾರ್ಬೊನೈಲ್ ಗ್ರೂಪ್ ಮೇಲೆ ಕಾರ್ಬೊನೈಲ್ ಗ್ರೂಪ್ ಗೆ ಅಟ್ಯಾಕ್ ಮಾಡೋಕೆ ನಾವು ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಏನ್ ಚಾರ್ಜ್ ಇರಬೇಕು, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇರಬೇಕಲ್ಲ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ದಿಸ್ ಈಸ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಇಸ್ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್. ಈಗ ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ವಿಲ್ ಅಟ್ಯಾಕ್ ವೆರಿ ಫಾಸ್ಟ್ಲಿ, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ವಿಲ್ ಬಿ ಅಟ್ಯಾಕ್ ವೆರಿ ಫಾಸ್ಟ್ಲಿ. ಇಫ್ ದಿಸ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕೆಪಾಸಿಟಿ ಇಸ್ ಲೆಸ್, ಈಗ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಕೆಪಾಸಿಟಿ ಕಮ್ಮಿ ಇದೆ ಅಂದ್ರೆ ಅಟ್ಯಾಕ್ ಆಫ್ ದ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ವಿಲ್ ಟೇಕ್ಸ್ ಸ್ಲೋಲಿ. ನೌ ದಿಸ್ ಇಸ್ ದ ರಿಯಾಕ್ಟಿವಿಟಿ ಆರ್ಡರ್. ಇಲ್ಲಿ ನೋಡಿ, ಈಗ ಫಸ್ಟ್ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಕೊಟ್ಟಿದ್ರೆ ಅಂದ್ರೆ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಅಲ್ಲಿ ನೋಡಿ, here this oxygen is a more electronegative group alla, it will pull this bond pair of electron towards itself. Now here we are having the more positive charge, now ಇಲ್ಲಿ ನೋಡಿ, here the ಜಾಸ್ತಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಯಾಕಂದ್ರೆ the groups attached are hydrogen, and it will not stabilize more, hydrogen compared to the CH3. Here ನೋಡಿ, CH3 is a plus I group ಅಲ್ಲ, plus I group ಅಂದ್ರೆ ಏನು, ಎಲೆಕ್ಟ್ರಾನ್ ರಿಲೀಸಿಂಗ್ ಗ್ರೂಪ್. ಈಗ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ಅಂದ್ರೆ ಈ ಕಾರ್ಬನ್ ಮೇಲೆ, now due to the presence of this plus I group, now it will give the electrons. When it is giving the electrons, now positive charge on this carbon will be decreased. Now ಈಗ positive charge on the carbon will be decrease ಆಗಿದೆ ಅಂದ್ರೆ attack of the nucleophile it will take somewhat time. Clear? Now that's the reason formaldehyde will react very fastly, because here the positive charge is having more strong. Now here due to the presence of more, as the more the plus I groups increases, carbonyl group reactivity order it will be decrease. Now this is the reactivity order. Next nucleophilic addition reaction. ಅಲ್ಲಿ ಈಗ if they have given strong nucleophile, this is a strong nucleophile ಅಲ್ಲ, cyanide is a strong nucleophile. Now first ಏನಾಗುತ್ತೆ, first attack of the nucleophile will takes place, and the last step ಅಲ್ಲಿ hydrogen will be takes place and will give the cyanohydrine, now cyanohydrine ಅಲ್ಲಿ, now you have to be very careful. Now cyanohydrine ಅಲ್ಲಿ, this is a cyanohydrine ಅಲ್ಲ, now this is a cyanohydrine. Now further reaction, ಈಗ further reaction ಕೇಳಿದ್ರಂದ್ರೆ cyanide on hydrolysis it will give the carboxylic acid, cyanide upon the hydrolysis it will give the carboxylic acid. Now cyanide upon lithium aluminum hydride, this is a reducing agent. Now this is a strong reducing agent. Upon the strong reducing agent ಇದು ಏನು ಕೊಡುತ್ತೆ, cyanide it will give the primary amine. Now ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, here this is acetaldehyde ಅಲ್ಲ, acetaldehyde in the presence of strong nucleophile in the presence of dilute base upon hydrolysis. Now cyanide carbonyl group ಏನಾಗುತ್ತೆ, same, then it will give the cyanohydrine. This cyanohydrine upon hydrolysis ಏನು ಕೊಡುತ್ತೆ, it will go to the lactic acid, ಇಲ್ಲಿ ನೋಡಿ. Now I kept this positive and negative, ಅಂದ್ರೆ this is a optically active compound. Lactic acid is a optically active compound. ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, this carbon is a chiral carbon ಅಂದ್ರೆ ಏನು, now the carbon attached group should be different ಅಲ್ಲ, ಬೇರೆ groups ಇರಬೇಕು. the carbon attached group should be different ಅಲ್ಲ, ಇಲ್ಲಿ ನೋಡಿ, this is CH3, this is OH, this is carboxylic acid ಮತ್ತೆ ಇದು H ಅಲ್ಲ, all the 4 groups attached to the carbons are different. ಅದಕ್ಕೆ this is a chiral carbon. Now ಅದಕ್ಕೆ lactic acid is a optically active compound. Chiral carbons are optically active. Most of the chiral carbons are optically active, not all the chiral carbons, most of the chiral carbons. Okay, next ಇಲ್ಲಿ ನೋಡಿ, next same in the HCl dilute base in the presence of ammonia, what it will give, first it will give the cyanohydrine, cyanide upon ammonia. Now what it will give, alanine is also a optically active compound, and this carbon is a chiral carbon. ಹೆಂಗಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, the carbon attached groups are the 4 ಬೇರೆ 4 groups ಅಲ್ಲ, attached groups are 4 different. That's the reason this is optically active compound. Next addition of sodium bisulfate. Addition of sodium bisulfate ಇಂದನು we can prepare the aldehyde. ಇಲ್ಲಿ ನೋಡಿ, this is acetaldehyde ಅಲ್ಲ, now addition of sodium bisulfate, now the product will get again the acetaldehyde only, but they will ask the byproducts. ಇದರಲ್ಲಿ they will ask the byproducts. Okay, now by that we will get the bisulfate addition product upon HCl, again we will get the acetaldehyde only. Sometimes they may ask the byproduct. These are the byproducts. ಇದರಲ್ಲಿ ಈಗ just now we have seen, now boiling point ಅಲ್ಲಿ ಏನು ನೋಡಿದೀವಿ, intermolecular hydrogen bonding ನೋಡಿದೀವಲ್ಲ. intermolecular ಅಂದ್ರೆ between the hydrogen bonding is between the where to where one compound to another compound. ಇದರಲ್ಲಿ ನೋಡಿ, here the proton transfer, intramolecular proton transfer, this is intra ಅಂದ್ರೆ within the molecule the proton is transferring, okay. Now next addition of alcohols. Now addition of alcohols in the, no, this is a carbonyl group ಅಲ್ಲ. Now carbonyl group upon the alcohol in the presence of dilute acid ಏನು ಕೊಡುತ್ತೆ, it will give the emiacetal ಮತ್ತೆ acetal. ಇಲ್ಲಿ ನೋಡಿ, aldehydes, if it is aldehyde group, if it is aldehyde group, aldehyde on reacting gives this is acetaldehyde ಮತ್ತೆ what it will give, emiacetal ಮತ್ತೆ acetal. If it is aldehyde, this reactant is aldehyde, what it will give, emiacetal ಮತ್ತೆ acetal. But ಇದರಲ್ಲಿ acetal ಮತ್ತೆ emiacetal ಅಲ್ಲಿ ಯಾವುದು is more reacting ಅಂದ್ರೆ acetal is more reacting. ಈಗ if it is a ketone, if the reactant is a ಕೀಟೋನ್. ಈಗ ಕೀಟೋನ್ ಇದೆ ಅಂದ್ರೆ ವಾಟ್ ಇಟ್ ವಿಲ್ ಗಿವ್, ಫಸ್ಟ್ ಇಟ್ ವಿಲ್ ಗಿವ್ ದ ಹೆಮಿಕೀಟಾಲ್ ಮತ್ತೆ ಕೀಟಾಲ್. ದಿಸ್ ವಿಲ್ ಬಿಕಮ್ ದ ಹೆಮಿಕೀಟಾಲ್ ಅಂಡ್ ದಟ್ ವಿಲ್ ಬಿಕಮ್ ದ ಕೀಟಾಲ್. ಕೀಟಾಲ್ ಅಲ್ಲಿ ಹೆಮಿಕೀಟಾಲ್ ಮತ್ತೆ ಕೀಟಾಲ್ ಅಲ್ಲಿ ಯಾವುದು ಜಾಸ್ತಿ ರಿಯಾಕ್ಟಿಂಗ್ ಆರ್ ರಿಯಾಕ್ಷನ್, ಮೋರ್ ರಿಯಾಕ್ಷನ್ ಮೀನ್ಸ್ now ketol will be the more reactive. Ketol will be the more reactive. This is the addition of the alcohols. Next by the addition of Grignard reagent indanu we can prepare the what, we can prepare the aldehydes. Now illi nodi, this is a Grignard reagent alla. Now metal is the positive charge, alkyl is the negative charge. Now this is a carbonyl group. Now here oxygen is a more electronegative, it will take the bond pair of electron. ಈಗ ಇದು ಬಾಂಡ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ತಗೊಂಡಿದ್ರೆ ಅಂದ್ರೆ ಆಕ್ಸಿಜನ್ ಮೇಲೆ ಏನ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತಲ್ಲ. ನಾವು ಕಾರ್ಬನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ನಾವು ಹಿಯರ್ ದ ಆರ್ ಆಲ್ಕಲಿ ಇಸ್ ಅ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಲ್ಲ, ಅದಕ್ಕೋಸ್ಕರ ಇಟ್ ವಿಲ್ ಬಿ ಅಟ್ಯಾಕ್ಡ್ ಹಿಯರ್ ಅಂಡ್ ಹಿಯರ್ Mg it is having the positive charge. Now upon hydrolysis what we are getting the primary. This is the reaction species for the Grignard reagent. ಈಗ Grignard reagent ಅಲ್ಲಿ if they have taken formaldehyde, it will give the primary alcohol. Now next, ಈಗ if they have taken the acetaldehyde, it will give the secondary alcohol. Now ಈಗ if they have taken a ketone, it will give the 3 degree alcohol. Okay, 3 degree alcohol. Clear? Now by the Grignard reagent. Next, now addition of ammonia and its derivatives are very very important. Now they can ask the direct questions from this here. Illi nodi, here this carbonyl group, now this elimination of the water molecule will be takes place. Idralli the elimination of the water molecule will be takes place and will get the C double bond N Z. This Z, E Z ಅಲ್ಲಿ if these groups are present, in the place of Z, if it is H is present. Now in the place of Z, if the H is present, now that carbonyl derivative will become the imine. Now this will become, if it is H here, now this product name will be imine. Now if in the place of Z ಈಗ R ಇದೆ ಅಂದ್ರೆ now this product name will become Schiff's base. The product name will become Schiff's base. Now ಇಲ್ಲಿ ನೋಡಿ, if in the place of Z, EZ ಅಲ್ಲಿ ಈಗ H ಇದೆ ಅಂದ್ರೆ, ಈಗ ಈ ಪ್ಲೇಸ್ ಅಲ್ಲಿ H ಇದೆ ಅಂದ್ರೆ reagent ಅಲ್ಲಿ, in the place of reagent ಅಲ್ಲಿ, in the place of Z ಅಲ್ಲಿ ಈಗ H ಇದೆ ಅಂದ್ರೆ now that reagent name will become the ammonia. If it is R, ಈಗ R ಇದೆ ಅಂದ್ರೆ now that reagent name will become the amine. Okay, now when it comes to only ಏನ್ ಮಾಡಬೇಕಲ್ಲ, only the elimination of H2O. ಇಲ್ಲಿ ನೋಡಿ, elimination of H2O and it will give the product, and that product this Z derivatives. ಈಗ ಈ groups in the place of Z, ಈಗ ಈ groups attached ಇದೆ ಅಂದ್ರೆ that carbonyl derivatives will be this one and the product's name will be this one. Clear? Now this is very very important. ಈಗ ನೀವು this all carbonyl derivatives ಮತ್ತೆ products name ನೆನಪಿಟ್ಕೋಬೇಕು. Clear? Next, ಈಗ ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ನೋಡಿದಿವಲ್ಲ, ನಾವು ಈಗ ವಾಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ರಿಡಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ಹೆಂಗಂದ್ರೆ ರಿಡಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ ಟು ದ ಆಲ್ಕೋಹಾಲ್ಸ್. ಸಿ ಈಗ ಈ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಒಂದೇ ಒಂದು, ವಾಟ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ, ಈಗ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ದಿಸ್ ಈಸ್ ಆಲ್ಡಿಹೈಡ್ ಅಲ್ಲ, ಆಲ್ಡಿಹೈಡ್ ಇದು ಕೀಟೋನ್, ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್, ಎಸ್ಟರ್ಸ್, ಆಸಿಡ್ ಕ್ಲೋರೈಡ್ ಆರ್ ಆಸಿಡ್ ಆಲೈಡ್ಸ್. This functional group upon this table is very very important. ಈಗ ಈ table is very very important. ಯಾಕಂದ್ರೆ here if you remember, if you remember this table, you can predict the answer very fastly. ಯಾಕಂದ್ರೆ ನೋಡಿ, aldehyde upon the strong reducing agent, ಅದು lithium aluminum hydride, sodium borohydride, diborane and the metal in the presence of hydrogen. Now aldehyde groups ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ aldehyde groups upon lithium aluminum hydride. Now product what it is giving? It is giving the primary alcohol. It is giving the primary alcohol. Which one? Aldehyde is reduced by lithium aluminum hydride, sodium borohydride, diborane ಮತ್ತೆ metal in the presence of H2. Next, ketone. It will be reduced to the secondary alcohol. Ketone, it will be reduced to the secondary alcohol by the lithium aluminum hydride, sodium borohydride, diborane ಮತ್ತೆ metal in the presence of hydrogen. Next, this is carboxylic acid. Carboxylic acid is reduced by lithium aluminum hydride, but it is not reduced by the sodium borohydride. This is very very important. Sodium borohydride can reduce only the aldehydes ಮತ್ತೆ ketones, but it will not reduce esters ಮತ್ತೆ carboxylic acids. Esters ಮತ್ತೆ carboxylic acid is not reduced by the sodium borohydride. Okay, next, diborane ಮತ್ತೆ metal in the presence of aluminum, metal in the presence of hydrogen, it will be reduced. Next, acid alide. X is the halogen ಅಂದ್ರೆ chlorine, bromine, iodine, fluorine alla halogen groups. Now idralli it is also will give the primary alcohol. It will also give the primary alcohol. Reduction. ಈಗ ರಿಡಕ್ಷನ್ ಕೇಳಿದ್ರೆ ಅಂದ್ರೆ ರಿಡಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ ಆಲ್ಡಿಹೈಡ್ಸ್, ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್, ಎಸ್ಟರ್ಸ್, ಆಸಿಡ್ ಆಲೈಡ್ಸ್ will be converted into primary alcohol. Only ketone will be converted into secondary alcohol. Now ಇದರಲ್ಲಿ ನೋಡಿ here diborane will not reduce the acid. Diborane will not reduce the acid chloride or acid halides. Okay, now this chart is very very important. Next, now reduction of hydrocarbons. Now reduction of hydrocarbons in the we can see the reduction of hydrocarbon. First ಏನಂದ್ರೆ Clemmensen reduction. This is zinc and the mercury in the presence of HCl. Now what it is? Carbonyl group will be converted into alkane. Carbonyl group is reduced to the alkane in the presence of zinc Hg in the presence of acid. This is very very important. Clemmensen reduction ಮತ್ತೆ Wolff-Kishner reduction, they are repeatedly asking. Now here carbonyl group is reduced to the alkane. Now this is a mechanism. ಇಲ್ಲಿ ನೋಡಿ zinc it will be by losing its 2 electron. Now it is stable in the Zn plus 2. Now by taking this electron, now we'll get the alkane. Now this is a mechanism, you can see over it. Next, now Wolff-Kishner reduction in the we can prepare the we can reduce the carbonyl group. ಇಲ್ಲಿ ನೋಡಿ, this is hydrazine in the presence of base. Upon heating, here we are getting what we are getting. Here also it is getting the alkane. Carbonyl group is reduced to the alkane. Now this is a mechanism. Hydrazine. Now here only one thing you have to do. Here the H2 it will be there, right? H2 hydrazine alli H2 and this is H2 alla. Now elimination of water molecule. Now ammonia and its derivatives. Chart nodidivalla, ammonia and its derivatives. ಈಗ ಈ ಚಾರ್ಟ್ ನೋಡಿದ್ವಲ್ಲ, ನಾವು here the carbonyl group in the presence of hydrazine. ಇಲ್ಲಿ ನೋಡಿ hydrazine ಎಲ್ಲಿದೆ? ಇದರಲ್ಲಿ it is here the NH2 group it is there. If the NH2 group it is attached, this is NH2 hydrazine. Now hydrazine it is giving NH2 alla. Now it will give the hydrazone. It is giving the hydrazone. Carbonyl group in the presence of hydrazine, it is giving hydrazone. Now this hydrazone mechanism. Now this is a hydrazone mechanism. Illi nodi, this is a hydrazone mechanism. This hydrazone upon base it will give the here if you have taken ketone, then it will give the what it will give? Propane. Now this is the hydrazone. How the hydrazone, if it is reacting with the hydrazine, it is giving the hydrazone upon base, it will giving the what we are getting what we are getting? We are getting the let us assume this is CH3 carbonyl group. Okay, clear? Next oxidation reactions. ಈಗ ರಿಡಕ್ಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ನೋಡಿದ್ವಲ್ಲ, ನೆಕ್ಸ್ಟ್ ಆಕ್ಸಿಡೇಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಸಿ ದ ಟಾಲೆನ್ಸ್ ರಿಯೇಜೆಂಟ್. Now tolerance test will be given by the aldehydes or mirror test, silver mirror test. Tolerance reagent ಏನಂದ್ರೆ this is ammonium hydroxide in the presence of AgNO3, both the mixture to give the complex. Now ಈ complex ಅಲ್ಲಿ Ag2O ಇರುತ್ತಲ್ಲ, now this will give the Ag plus. Now this is the reacting species. Now this reacting species, now when that in that complex, ಈಗ test tube ಅಲ್ಲಿ if you drop in that complex, if you drop the aldehyde, now it will give the carboxylate anion and it will give the silver mirror. Now ಈಗ test tube ಅಲ್ಲಿ this here the mirror, silver mirror type it will give. Now means aldehyde is oxidized to the carboxylate anion and it will give the silver mirror test. This we called as a tolerance reagent. Next is the feelings test. Feelings ali feelings A is the copper sulfate and feelings B will be the Rochelle salt. This is a Rochelle salt or potassium tartarate. This is a potassium. Now in the place of here the negative ideyalla, if it is a K, it is present. If the K is present, then it will become the what is become potassium tartarate. If the K is present, that's the reason if I remove this is the tartarate, if I add a K plus, then it will become the potassium tartarate. Now eagerly potassium tartarate ali, now if the aldehyde is dropped in the feelings A and B, again it will give the anion and it will reduce it to the Cu, copper oxide. This is a reddish PPT. Now this reddish PPT, then by that this is the feelings test. Feeling test ali will get the reddish PPT. This is very important. Aldehydes, aromatic aldehydes will not reduce or will not respond to the feeling test. Aromatic aldehydes will not give the test for the which one? Feelings test. Next iodoform test. This is also very important. Iodoform test kodoke these two groups are very important. Here CH3C double bond O, this group irbeku. To give the iodoform test, this CH3C double bond O, here the R is there alla. Now R ali if should not be, ಈಗ R ಅಲ್ಲಿ if it is hydrogen, if it is CH3, if it is any isopropyl group or any alkali group, if it is present, then it will give the iodoform test. R ಈ R place ಅಲ್ಲಿ ಈ R place ಅಲ್ಲಿ if these groups are attached, ಈಗ ಈ groups attached ಇದೆ ಅಂದ್ರೆ it will not give the iodoform test. Now ಯಾಕಂದ್ರೆ here this will be the, then if I attach here the OH, it will become the acid. ಅಂದ್ರೆ here the R, it should not be acid ಮತ್ತೆ acid derivatives ಇರಬಾರದು. ಓಕೆ, ಇದರಲ್ಲಿ acid ಮತ್ತೆ acid derivatives ಇರಬಾರದು. ಕ್ಲಿಯರ್? Now here the R, it should not be there. Now iodoform test ಕೊಡೋಕೆ ಈಗ in the place of CH3 OH ಇದೆ ಅಂದ್ರೆ ಇದರಲ್ಲಿ acidic hydrogen ಇರಬೇಕು. Now acidic hydrogen now ಏನಾಗುತ್ತೆ by Collins reagent ಮತ್ತೆ or PCC. ಈಗ oxidation reaction ಅಲ್ಲಿ by oxidation reagent ಏನಾಗುತ್ತೆ, it will be converted into ketone ಅಲ್ಲ, it will be converted into ketone. Again this reaction will be proceed. These groups are very important. Now to give the iodoform test, now these two groups are very very important. ಈಗ iodoform question ಕೇಳಿದ್ರ ಅಂದ್ರೆ ಮೊದಲು ನೀವು ಏನ್ ಚೆಕ್ ಮಾಡ್ಬೇಕಂದ್ರೆ whether this group is present or not. ಈಗ CH3C double bond ಇದೆ ಅಂದ್ರೆ here the attached group are here the attached groups ಇದು ಇರಬಾರದು. These groups it should not be there. ಈಗ if CH3COH ಈಗ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ ಈ ಕಾರ್ಬನ್ ಅಲ್ಲಿ ಎಸಿಡಿಕ್ ಹೈಡ್ರೋಜನ್ ಇರಬೇಕು. ಓಕೆ, ಈಗ ಇದರಲ್ಲಿ ಎಸಿಡಿಕ್ ಹೈಡ್ರೋಜನ್ ಇಲ್ಲ ಅಂದ್ರೆ it will also not give the iodoform test. It will also not give the iodoform test and it will give the yellow color PPT, and this is the sodium salt of carboxylic acid. This is the iodoform test. Okay, next. Next, reaction due to the alpha hydrogens. This is very very important. Now named reactions. Now the named reactions are very very important. Now reactions of the alpha hydrogens. Alpha hydrogens ಏನಂದ್ರೆ functional group adjacent carbon. Functional group adjacent carbon ಗೆ carbon ಇರುತ್ತಲ್ಲ, functional group adjacent. Let assume this is C double bond CH2. Now here this is CH3 ಅಲ್ಲ. Now ಇದು functional group ಅಲ್ಲ. This is alkene is the functional group. Alkene ಪಕ್ಕದಲ್ಲಿ ಇದು carbon ಇದೆಯಲ್ಲ. Now this carbon is a alpha carbon. Alpha carbon ಅಲ್ಲಿ hydrogens ಇದೆಯಲ್ಲ, these are the alpha hydrogens. These are the alpha hydrogen. ಇಲ್ಲಿ ನೋಡಿ, that is first is the aldol condensation. Aldol condensation ಅಲ್ಲಿ with alpha hydrogen carbonyl compounds with the dilute base will give the beta hydroxy carbonyl compound. Beta hydroxy carbonyl compounds upon dehydration gives alpha beta unsaturated compounds. Now it is an example of the carbanion addition. Alpha hydrogens are more acidic. ಇಲ್ಲಿ ನೋಡಿ, alpha hydrogens are more acidic. ಈಗ aldol condensation ಕೊಟ್ಟಿದ್ರ ಅಂದ್ರೆ if ಈಗ ನೀವು ಆ ರಿಯಾಕ್ಷನ್ ಫೈಂಡ್ ಮಾಡಿದಾಗ if you got to know that is a aldol condensation, there you have to take the 2 moles of the compound. 2 moles of the reactant you have to take. In the question they will not give the 2 moles. In the question they will not specify the 2 moles. Okay, now ಇಲ್ಲಿ ನೋಡಿ, this is a acetaldehyde ಅಲ್ಲ. Acetaldehyde in the presence of dilute base readily it will abstract the acidic hydrogen. It will abstract the alpha hydrogen. Now this is a functional group ಅಲ್ಲ. Aldehyde group is a functional group. Functional group adjacent carbon is a alpha carbon. Alpha carbon ಅಲ್ಲಿ hydrogen ಇದೆಯಲ್ಲ. Now this is a acidic hydrogen. Now acidic hydrogen, now this will take the proton. Now here it will get the positive charge. Now this positive charge is stabilized by the resonance. This negative charge is stabilized by the resonance. That's the reason alpha hydrogens are more acidic. Clear? Now here CH2 minus C double bond H ಈಗ ಒಂದಿದಲ್ಲ. Now another mole of acetaldehyde we have to take. Now ಇದರಲ್ಲಿ this pi bond will be shifted toward this oxygen. Here the carbon will get the positive charge and negative charge will be attacked. And we'll get this product by upon hydrolysis we'll get this product, alpha beta unsaturated carbonyl compound will get. One shortcut I will say. Now ಈಗ ಈ product ಬಂದಿದಲ್ಲ, this product it came right. Now here this is a mechanism. Now shortcut ಏನಂದ್ರೆ here the CH3 C double bond H ಅಲ್ಲ, C double bond H. ಈಗ ನೀವು ಏನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ this is alpha hydrogens ಅಲ್ಲ, alpha hydrogens. Now this is hydrogen. Now this is alpha hydrogens. Now ಇನ್ನೊಂದು acetaldehyde ತಗೋಬೇಕು. Now here the elimination of H2O. By the elimination of H2O, now the product what you will get? CH3 carbon. Now ಇದರಲ್ಲಿ hydrogen. Now double bond. Now here carbon. Now ಇದರಲ್ಲಿ hydrogen. Now C double bond H. Now ಇಲ್ಲಿ ನೋಡಿ, ಎರಡು ಸೇಮ್ ಅಲ್ಲ, ಸೇಮ್. CH3 C single bond H double bond C single bond H ಮತ್ತೆ aldehyde group ಇದರಲ್ಲಿನೂ ಸೇಮ್. CH3 C H double bond CH C double bond H ಅಲ್ಲ. Now here this is the shortcut. So, elimination of the water molecule takes place. Now here it will give the alpha beta unsaturated carbonyl compound. Now this is a mechanism, and that is a shortcut to find out the aldol condensation. Okay, next. Now here these are the no alpha hydrogens. E compound ಅಲ್ಲಿ ಈಗ if they have given ಒಂದು next if they have given ಒಂದು CH3 C double bond OH ಇದರಲ್ಲಿ alpha hydrogens ಇದೆಯಲ್ಲ now next now ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಕೊಟ್ಟಿದ್ರಂದ್ರೆ there is no alpha hydrogens ಯಾಕಂದ್ರೆ this is functional group adjacent carbon ಇಲ್ಲಲ್ಲ ಅದಕ್ಕೆ this is no alpha hydrogens ಇದು alpha hydrogens ಇದೆಯಲ್ಲ now reaction how it will proceed ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ C double bond H now ಇದರಲ್ಲಿ C hydrogens ಮತ್ತೆ hydrogens and hydrogen alpha hydrogens ಇದೆಯಲ್ಲ now here formaldehyde ಅಲ್ಲಿ hydrogen ಮತ್ತೆ hydrogen. Now the elimination of water molecule will be takes place and we will get the CH2 C double bond H formaldehyde. Now this is the product. Okay, now hydrogens will be eliminated from the alpha carbons only. Okay, hydrogens will be eliminated from the alpha carbons only if the alpha carbon in that compound in that reactant if there is no alpha hydrogens oxygen will be eliminated and if another species or another reactant it is having the alpha hydrogens will be eliminated from the alpha carbon only. Okay, to find out the aldol condensation. Okay, next these are not having the alpha hydrogen. Illi nodi this is functional group here this is 3 degree carbon alla 3 degree carbon it is not having the alpha hydrogens. Okay, here also there is not having the alpha hydrogens. Now in these compounds alpha hydrogens are present. This is alpha carbon. Now idralli this is alpha carbon. Now this is alpha carbon. Now this is alpha carbon. This is also alpha carbon. Okay, next cross aldol. ಈಗ cross aldol ಕೊಟ್ಟಿದ್ದೀರ ಅಂದ್ರೆ cross aldol ಅಲ್ಲಿ ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಫಸ್ಟ್ ಇಲ್ಲಿ ನೋಡಿ here what is this is acetaldehyde again this is CH3 CH2 C double bond H ಅಲ್ಲ now ಇಲ್ಲಿ ನೋಡಿ this also having the alpha hydrogens ಇದರಲ್ಲಿ for this also it is having the alpha hydrogens ಅಲ್ಲ ಎರಡು it is having the alpha hydrogens. now first ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ 2 moles of acetaldehyde reacts to give the alpha beta unsaturated carbonyl compound that we call it as a self aldol. 2 moles itself it is reacting. Again this also it will react itself because here also it is having the nodi CH3 CH H C double bond H. Now ಇಲ್ಲಿ ನೋಡಿ now C double bond H now CH2 CH3. Now elimination of water molecule it will be takes place. Now what it will give CH3 C double bond C here one hydrogen. Now ಇದರಲ್ಲಿ C double bond H now ಇದರಲ್ಲಿ CH2 CH3 ಇಲ್ಲಿ ನೋಡಿ same product okay CH3 CH2 CH CH3 CH2 CH double bond now CH3 CH2. Okay, clear? Now this is self aldol, this is also self aldol. Next cross aldol ಏನಂದ್ರೆ here also it is having the alpha hydrogens, here also it is also having the alpha hydrogens. From one reactant oxygen will be eliminated, from one reactant hydrogens will be eliminated. Clear? Next Cannizzaro reaction. Next, this is also very important named reaction, that is a Cannizzaro reaction. ಈ Cannizzaro reaction ಅಲ್ಲಿ aldol condensation ಮತ್ತೆ cross aldol condensation it will takes place with the alpha hydrogen. Cannizzaro reaction will takes place with the without alpha hydrogens. Now without alpha hydrogens, see, without alpha hydrogens aldehydes with the concentrated base it will give the acids ಮತ್ತೆ it will give the acids and the bases. Now it is a redox reaction. Now Cannizzaro reaction is a redox reaction. ಇದರಲ್ಲಿ H plus ಮತ್ತೆ OH minus are the nucleophiles involved in this Cannizzaro reaction. Now intermolecular hydride ion transfer takes place. ಮತ್ತೆ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಪ್ರೋಟಾನ್ ಟ್ರಾನ್ಸ್ಫರ್. ಹೈಡ್ರೈಡ್ ಅಯಾನ್ ಅಂದ್ರೆ H ಮೈನಸ್, ನೋ ಪ್ರೋಟಾನ್ ಅಂದ್ರೆ H ಪ್ಲಸ್. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್, ಯು ಹ್ಯಾವ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. ನೋ ಹೈಡ್ರೈಡ್ ಅಂದ್ರೆ H ಮೈನಸ್, ಪ್ರೋಟಾನ್ ಅಂದ್ರೆ H ಪ್ಲಸ್. ಕ್ಲಿಯರ್? ನೋ ಇದರಲ್ಲಿ ಎರಡು ಇಟ್ ವಿಲ್ ಬಿ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ನೋ ಮೆಕ್ಯಾನಿಸಮ್ ಇಲ್ಲಿ ನೋಡಿ. ನೋ ದಿಸ್ ಇಸ್ ಅ ಮೆಕ್ಯಾನಿಸಮ್. ನೋ ದಿಸ್ ಇಸ್ ಅ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಅಲ್ಲ, ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ concentrated base. What we are getting? We are getting the salt plus acid, salt plus alcohol, salt plus acid plus alcohol we are getting, right? Here nodi, we are getting acids plus bases or salt, base salt, that is a base salt. Now first here the OH, it will be addition of OH, it will be takes place and it will give the this compound. Next, transfer of hydride shift, H minus ion, transfer of H minus ion will be takes place. Now here this negative charge, it will delocalize and it will take the bond pair of this hydrogen, will take the bond pair of electron towards itself. While taking the bond pair of electron towards itself, now here we'll get this compound, here we'll get this compound. Clear? Now next the proton transfer. Here by this proton transfer we are getting the what? Base plus acid, base plus acid. Now this is the mechanism for the Cannizzaro reaction. Next we are going to see the electrophilic substitution reaction. Next we are going to see the electrophilic substitution. Electrophilic substitution reaction. Now electrophilic substitution reactions are very very important. Now yakandre illi nodi, this is aldehyde group alla, this is aldehyde group. Now aldehyde group will comes under the minus I as well as the minus M, minus I and the minus M. But minus M ಮತ್ತೆ minus I ಅಲ್ಲಿ minus I is more dominating than the minus I. Minus M is more dominating than the minus I. Minus M groups are meta directing groups. Meta directing groups andre electrophile will go and attack at the meta position. Electrophile attack at meta position. At meta position ಅಲ್ಲಿ electrophile will be attack. ಇಲ್ಲಿ ನೋಡಿ, now halogenation ಅಲ್ಲಿ Cl is the electrophile, it is attack at the meta position. Now next nitration ಅಲ್ಲಿ NO2 is the electrophile is attacked at the meta position. Sulfonation ಅಲ್ಲಿ SO3H is the electrophile, it is attacked at the meta position. Now this is the electrophilic substitution reaction. Okay, next carboxylic acid. Next topic, what is the meaning of the next topic? ಯಾವ್ದಂದ್ರೆ carboxylic acid. ನಾವು ಇಲ್ಲಿ ನೋಡಿ carboxylic acid, this is C double bond, ಇದರಲ್ಲಿ OH ಇರಬೇಕಲ್ಲ. ನಾವು OH, if it is, this is acetic acid. Now here this carbonyl compound, now this is sp2, this is sp2. now here this is acetic acid, now this is benzoic acid. Now this is a benzoic acid. Now this is the acetic acid, that is a benzoic acid. Now next we'll see the methods of preparations of the carboxylic acid. ಈಗ we'll ನೋಡಿದೀವಲ್ಲ methods of preparations of aldehydes ಮತ್ತೆ ketones. ಇದರಲ್ಲಿ ನಾವು ಏನು ನೋಡ್ತಾ ಇದೀವಿ? methods of preparations of the carboxylic acid. Now first methods of preparations of carboxylic acid ಅಲ್ಲಿ ನಾನು ಹೇಳಿದನಲ್ಲ, what I said strong oxidizing agent. ಈಗ strong oxidizing agent ಕೊಟ್ಟಿದ್ದೀರಾ ಅಂದ್ರೆ K2Cr2O7. now these are the strong oxidizing agents alla, strong oxidizing agent. The primary alcohol will be converted into these two. Primary alcohol will be converted into carboxylic acid, right? Primary alcohols will be converted into carboxylic acid due to the presence of strong oxidizing agent. ಈಗ if due to the presence of ಈಗ secondary alcohol ಕೊಟ್ಟಿದ್ದೀರಂದ್ರೆ now this will be converted into ketone. But primary alcohols only will be converted into carboxylic acid. ಇಲ್ಲಿ ನೋಡಿ, ಇದರಲ್ಲಿನೂ primary alcohol, ಇದರಲ್ಲಿನೂ primary alcohol. Okay, clear? Now by the strong oxidizing agent we can prepare the carboxylic acid. Next from the oxidation of aldehydes and the ketones. ಈಗ aldehydes due to the strong oxidizing agent, aldehydes also will reduces to the carboxylic acid. Now due to the presence of this strong oxidizing agent, this is a nitric acid. Nitric acid also will be converted into acetic acid. Next, hydrolysis of the nitrile. Now nitrile andre C triple bond N alla, C triple bond N. Now upon hydrolysis ನಾನು ಹೇಳಿದನಲ್ಲ, what nucleophilic addition reaction ಅಲ್ಲಿ now cyanide upon hydrolysis it will give the carboxylic acid alla. Now this is only cyanide upon hydrolysis it is giving the carboxylic acid. Now nucleophilic addition reaction ಅಲ್ಲಿ ನಾನು ಹೇಳಿದನಲ್ಲ, what I said, cyanides upon hydrolysis it will give the carboxylic acid. Now this is a mechanism. Cyanide upon hydrolysis it will give the carboxylic acid. Now this is cyanide upon hydrolysis it will giving the benzoic acid. Now this is giving the acetic acid. Next Grignard reagent indanu we can prepare the carboxylic acid. Grignard reagent indanu we can prepare the carboxylic acid. Now this is a CO2. Now this is a CO2. Now here the oxygen mele positive charge, yakandre this oxygen carbon ಮತ್ತೆ oxygen is a more electronegative group alla. Now this will get the positive charge, this will get the negative charge. Grignard reagent alli negative will go and attack here, the positive will go and attack here, and will get the this compound upon hydrolysis here the H will be attacked and here the OH. This is the magnesium hydroxybromide and the what we are getting carboxylate. Now e preparation indanu we can prepare the carboxylic acid. Next now preparation of aromatic acids from the alkali benzene. Now ಒಂದೇ ಒಂದು ನೆನಪಿಟ್ಕೋಬೇಕು. Now whatever may be the side chain, now iga if they have given a toluene, if they have given a long chain, whatever may be the side chain, benzene ಮೇಲೆ side chain ಏನಾದ್ರೂ ಎಷ್ಟು ದೊಡ್ಡ ಲೆಂತ್ ಇರಬೇಕು. Now upon strong oxidizing agent directly it will convert into carboxylic acid. This is very important, ನೀವು ನೆನಪಿಟ್ಕೋಬೇಕು. Clear? Now ಇಲ್ಲಿ ನೋಡಿ alkali benzene containing benzylic hydrogen atom. Here ಇಲ್ಲಿ ನೋಡಿ this benzene attached carbon is a benzyl. What is there again? Benzylic hydrogen. These are the benzylic hydrogens alla hydrolyzed by the alkaline or acidic KMnO4 will give the carboxylic acid. ಇಲ್ಲಿ ನೋಡಿ entire side chain containing primary secondary alkali groups of the benzene ring is oxidized to the carboxylic acid group irrespective of the length of the side chain. That will be converted into carboxylic acid group. ಇಲ್ಲಿ ನೋಡಿ here the CH3, here the CH3 that converted into carboxylic acid. ಇದರಲ್ಲಿ ಎಷ್ಟು ದೊಡ್ಡದು carboxylic acid side chain ಇದೆಯಲ್ಲ, that also it will be converted into carboxylic acid only. This is very important. Now next effect of substitutions of acids of the carboxylic acid. Effect of substitutions of the carboxylic acids andre here ಇಲ್ಲಿ ನೋಡಿ carboxylic acid. So this is a carboxylic acid. Now this is a carboxylic acid is a -M as is a -I. -M ಮತ್ತೆ -I ಅಲ್ಲಿ -M is a more dominating than the -M is more dominating than the -I. ಈಗ carboxylic group ಅಲ್ಲಿ acidic acids ಕೇಳಿದ್ರಂದ್ರೆ acidic nature of the carboxylic acid ಕೇಳಿದ್ರಂದ್ರೆ any group here ortho position ಅಲ್ಲಿ any group either it is a -M, either it is a -M group or the +I group. -M groups are the +I groups. Iga if any alkali groups, or else let's take if any alkali group, if it is attached, this is strong acid, this we call it as a ortho effect. Now here benzoic acid at ortho position if any group is attached, if any group is attached, that is strong acid. Okay, now ಈಗ ಇಲ್ಲಿ ನೋಡಿ if COOH, now ಇದರಲ್ಲಿ CH3 COH, now here the CH2 ಮತ್ತೆ CH3. Now if the bulky group is increased at the ortho position, now its acidic nature will be increased. Okay, now this we call it as a ortho effect. Next, if CH3, next CH3. Now, if this group is plus I group alla, now plus I group ಏನ್ ಮಾಡುತ್ತೆ, it will decrease the acidic nature of the carboxylic acid. But here this is the ortho effect alla, this is ortho effect. Due to the ortho effect, this is strong acid. First, second and third. ಇದರಲ್ಲಿ what it will be, here it is having hyper conjugation, non bonding resonating structure irutte here. Next this one and this. Clear? Now next esterification ಏನಂದ್ರೆ ಏನಿಲ್ಲ, esterification ಅಲ್ಲಿ ಇಲ್ಲಿ ನೋಡಿ, ಫಸ್ಟ್ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಇದೆಯಲ್ಲ, this is carboxylic acid. Now carboxylic acid in the presence of alcohol, now here H plus. Now this is acid H plus, it was attacked by the oxygen lone pair. Now ಏನಾಗುತ್ತೆ, here C positive charge, here OH. Okay, now you are having the alcohol. Now here the oxygen mele positive charge is unstable. Now here we'll get the positive charge alla, then it will get come R OH. Now this is the OH. Now this is a positive charge. Now here the R OH ideyalla. Now this will be attacked here. Now here C OH. Now here the OH. Now idaralli OH, oxygen mele positive charge. This is R dash. Now to stabilize this one, this hydrogen will give the bond pair of electron, then we'll get the R COH, ಮತ್ತೆ ಇದರಲ್ಲಿ H, ಮತ್ತೆ ಇದರಲ್ಲಿ O, ಮತ್ತೆ R dash. Now ಒಂದು ಕಾರ್ಬನ್ ಮೇಲೆ ಎರಡು ಹೈಡ್ರಾಕ್ಸಿ ಗ್ರೂಪ್ಸ್ ಆರ್ ಅನ್ಸ್ಟೇಬಲ್ ಅಲ್ಲ, the elimination of water molecule takes place, will takes place, and we'll get the R C double bond O, R C double bond O, O R dash. Now these are the esterification reaction. Reactivity of the alcohol toward the esterification is ethanol, primary alcohol, secondary alcohol, and the tertiary alcohol. Clear? Now this is the mechanism. By this we have ended our summary lecture. Clear? Now bye.